Hello everyone. Today we cover trigonometric functions of angles, section 6.3. We continue working with triangles and we are going to connect triangles, the sides of right triangles to trigonometric functions. So you probably remember that we had something like this. If you do know the coordinates of the point on a terminal side of an angle, for example, you have a point somewhere here, and that's point P, and has coordinates x and y. Then you can calculate all 6 functions of this angle theta using these coordinates, right? Remember that if the points are sitting on unit circle, then cosine of theta is equal x, sine of theta equals y, and tangent of theta equals y over x. But if point does not sit on the unit circle, then we have to adjust our cosine, sine, and, well, not tangent actually, tangent is still going to be same, to the fact that the distance from the origin to the point is not equal to 1 anymore. It equals to r. Remember, how do we find r? R, it's a distance from origin to our point, so it's square root out of x squared plus y squared. So adjusted sine and cosine. Well, tangent is not going to be adjusted actually, right? We remember tangent is sine over cosine, but if you put sine and cosine into this tangent equation, r is going to just disappear. So that's how we find actually sine, cosine, and tangent basic trigonometric functions if you do know the coordinates of the point. Well, let's just calculate for one specific point maybe, or just imagine somebody gives us point P with coordinates -3, 5, and they're asking us, what is cosine of the angle theta, which is going to be like our terminal, it has terminal side going through the point P. Well, remember, cosine is x over r, so I'm going to write down x over r, and my x is actually -3. What is my r? It's a square root of x squared, so -3 squared plus y squared, 5 squared, right? And we are going to have -3 over square root of 9 plus 25, which is going to be minus square root of 34. Well, that's going to be my cosine. And the same way we can calculate sine. For sine, it's going to be easier because we do know r already. So we just take y, which is 5, and divide by our r, which is, we do know that's square root of 34. And for tangent, you even don't need to know r, actually. You just divide y over x. So y is 5, and x is -3. So it's -5 over 3. Okay, well, basically that's all you need to know about like the coordinates and angles. We do remember this already. We learned this already. Just a little review. Now let's review a reference angle, because what I've seen in your quiz is that not everyone understands what is reference angle and how to calculate it. We choose a different color. So reference angle. Well, if you remember, you just need to review it. If you don't remember, learn it again. Imagine that somebody gives you angle theta. What is going to be reference angle to angle theta? How it's defined? First, we have theta with a bar. Bar tells it's a reference angle. Now, how to calculate it? Actually, we are going to find the acute angle between terminal side of your like angle theta and x-axis. In this case, the acute angle is going to be over here, right? If you draw the angle over here, you are going to have a pseudo angle. So that's going to be a reference angle. Well, let's just maybe find a couple of reference angles. For example, theta equals 5 pi over 6. Well, what is going to be theta bar, reference angle? Question. Well, I'm going to draw a little unit circle. And we remember that 5 pi over 6, it's almost pi, but a little bit less, right? So 5 pi over 6 is going to be something like this. So reference angle is going to be this one, complementary 2 pi, right? So we calculate it by writing down pi minus 5 pi over 6. It's going to give us pi over 6. Reference angle is always going to be positive. Normal angle can be positive or negative. Reference angle is always positive. One more example. Imagine theta equals 4 pi over 3. Oh, I don't want to draw another unit circle. I'm going to just use this one. So we have angle 4 pi over 3, which sits in the third quadrant, right? And the reference angle here is going to be, well, let me make it green. I'm going to label it 2 times over here. This one, right? So we're going to calculate it as theta reference equals, well, here we are not going to subtract it from pi. Actually, we are going to subtract pi from our angle, right? So 4 pi over 3 minus pi is going to give us pi over 3. Why? Because the angle is bigger than pi, and the leftover angle is going to be our reference angle. Okay, so that's all about reference angles. Well, why do we need reference angles? They are very convenient if you remember the table. Let me kind of write down the table one more time. The table, which is like describing basic angles of the first quadrant. So remember theta, sine of theta, cosine of theta, and tangent of theta, right? And we're going to start with 0. So sine of 0 is 0, cosine is 1, and tangent is 0. And the next one is going to be pi over 6. And that's going to give us 1/2 for sine, square root of 3 over 2 for cosine, and 1 over square root of 3 for tangent. Pi over 4, symmetrical for sine and cosine, 1 over square root of 2, 1 over square root of 2, and tangent is going to be equal to 1 because it's a ratio between these two same square roots, right? Pi over 3 is going to kind of exchange the numbers for pi over 6, right? It's a square root of 3 over 2, and 1/2 for cosine. And for tangent, that's a square root of 3, so it's kind of flipped over this one. And the last one is pi over 2. And we have 1 for sine, 0 for cosine, and undefined angle. And I'm going to put actually infinity to show that's a positive infinity. The tangent goes to infinity. Now, how do we use it? Okay, for example, somebody is asking us, please calculate tangent of 4 pi over 3. And you know that 4 pi over 3 has reference angle of pi over 3, right? We just calculated it. So you're going to put the tangent of 4 pi over 3 equals pi over 3. It's the same angle. But we do know that in this quadrant, that's a third quadrant, right? Tangent is positive. And this one is positive, so we're already kind of done with our calculations. So what is tangent of pi over 3? From the table, tangent of pi over 3 is a square root of 3. So we're just going to write down that it equals square root of 3. And that's how we use reference angles. Well, to use reference angles, you will need to remember how unit circle or signs of the functions in quadrant. For example, tangent is plus, minus, plus, minus. Remember what is cosine. Cosine is plus, plus, minus, minus. How do we know this? X is positive here and negative here. And the last one, sine of theta, because it's y, it's going to be positive here and here, and negative here and here. Okay, so if we do remember this, fine, we already know everything. Now, guys, remember that once I was giving you, for example, tangent of some angle, I was asking how calculate the cosine. Let me kind of write down the problem. Example. Well, example 2, I guess, right? We should have example 1, example 2. Somebody, like, imagine that you know that tangent of some angle equals, I don't know, 2 over 3. And you know that the angle theta belongs to a third quadrant. How to calculate the cosine of theta? Before I was asking you to use identities, right? Identities means that cosine and tangent are connected as a secant and tangent, and then you calculate the cosine from secant and then calculate sine, or like just stay at cosine. Now, how we can do it now? Because we do know that reference angles are going to give us same numbers for tangent, sine, and cosine. And the sine can be defined by using quadrants. Well, we can use triangles to calculate actually cosine. Remember that in a right triangle, tangent is what? Opposite side over adjacent, right? I'm going to write it down. That tangent of theta, opposite over adjacent side. So in our case, it's 2 over 3, so we can assume that opposite side is equal to 2, and adjacent side is equal to 3. Because it's a right triangle, we can calculate the hypotenuse using Pythagorean theorem, right? Hypotenuse c squared equals a squared plus b squared. And in our case, it's going to be 2 squared plus 3 squared, which is going to give us what? 4 plus 9 is going to give us 13. Well, okay, we do know hypotenuse, how it helps us. Well, we can calculate cosine of this triangle, right? We remember that cosine of theta is what? Adjacent side over hypotenuse. So adjacent side is 3, hypotenuse is a square root of 13. Why square root? Because 13 is c squared, right? So if I want to just know c, I have to extract the square root. Somehow I have some strange dots keep appearing on my screen. Okay, so we are almost done. We just need to adjust the quadrant, right? Remember that angle is in the third quadrant. And if you draw a unit circle for cosine, we did it on the previous page, but because I scrolled it up, I don't have it. For cosine, we have plus, plus, minus, minus. In the third quadrant, it's minus. So our cosine is going to have extra minus here. And you don't need to use any identities. You just use a right triangle and calculate all the functions. You can calculate same way sine or secant or cosecant or cotangent. You know, you already know everything about this triangle, so you can calculate any function. The only kind of thing to watch is where the point sits or where the angle is, which quadrant. If the angle sits in the first quadrant, everything is safe, everything is positive. But anything else is going to require kind of considering the signs of the functions in quadrant. Okay, well, I'm going to kind of label that this is a square root of 13, so a bit more clear. Now, what else are we going to learn in this section? In this section, we are going to learn areas of triangles. I want to move to a different page, so we don't mix it up. Areas of triangles. Well, I'm going to kind of prove a formula, initial formula for area of the triangle. If you know the formula, okay, skip the proof. If you don't know, maybe it helps you to understand. Imagine that you have a triangle. And you want to find the area. Area of this triangle is a question. What you can do, guys. If you do know the height of this triangle H, and you do know this side, base, you can actually very easy calculate the area of the triangle by doing additional triangles over here. I'm going to draw a line parallel to my base and draw 2 extra triangles. You see that my extra triangles are exactly the same as my triangles, part of my triangle here. So this triangle is same with this. Why? Because they have same hypotenuse, that's a right angle. These 2 sides are parallel, means that they are equal. These 2 sides are parallel, they're equal, right? So if you look at this triangle and compare it to the area of rectangle you have, I'm going to shade a rectangle in green. And the triangle, let me change the color, triangle in blue, triangle. You see that rectangle is twice bigger area than triangle, right? Just because rectangle consists out of 4 triangles and triangle consists out of 2. So what I'm going to do, I'm going to raise a question mark here, and I'm going to write down that area equals 1/2 of the area of rectangle. What is the area of rectangle? Well, that's a side, and my height here is going to be same as the side here and side here. So it's going to be h multiplied by b. That's a formula for area of the triangle. You probably know this from somewhere like middle school or like, I don't know, maybe your other math class. Now, well, let's just calculate something. For example, somebody gives you a side b equals 5 and the height of the triangle equals 2, and they're asking what is the area. Well, you just use the formula and write down that area is 1/2 height by the base, right? 2 and 2 are going to get canceled, and we are going to have area equals 5. Okay, that's the first case. First case when you have base and the height. Case 2. What if somebody gives you slightly different parameters of the triangle? They won't give you a base and the height. They give you base and another side over here. And they give you angle between these two sides. Can we calculate area in this case? Well, we already know trigonometry of right triangles, so if we draw the height here, we can calculate it from right triangle over here, right? Remember that height is opposite side divided over hypotenuse A is going to be sine of angle theta, or where height will be equal A sine of theta. Now we do know height, and we are going to just go back to my formula. We are going to write down that area equals 1/2 A sine of theta multiplied by base. Usually, guys, people are keeping like letters together, and the sign sits like at the very end. That's going to be a new formula for area, right? Well, let's just calculate maybe one example here. We change the color. So, sorry. Example 1. So somebody gives me B, which is equal 5, right? And somebody gives me A, which is equal 4, and somebody gives me theta, which is equals to 30 degrees. And they're asking, what is the area? Well, I use the formula. 1/2 side A is 4, side B is 5, and the sine of 30 degrees, we remember, equals 1/2. So we have 1/2 from the formula. 4 by 5 by 1/2. This 1/2 is a sine of 30 degrees. 1 equals 1/2. This 1/2 comes from the formula. Well, when we see in denominator 2 and 2, which is 4, cancels with this 4, and we have 5 again. Well, you see that two different problems are solved and give you same result. Just use different formulas. I want to consider one more example, but that's going to be the last example for this lecture. Example 2. Imagine somebody gives you a circle, and they tell you that the radius of this circle is, I don't know, 2. And somebody builds a triangle on this circle like this. And the angle over here, angle theta, is equal to 60 degrees. And they're asking, okay, what is the area of this triangle? Well, again, we use the formula, right? Do we know the sides of the triangle? Well, actually, no, but we do know that these sides are making the radius. So this side is 2 and this side is 2. So we have 1/2 from the formula. A is equal to, B is equal to, and we multiply, sorry, too early to write down equal sign. We multiplied by sine of 60 degrees. Well, we can cancel 1 of 2 with each other, right? And we have 2 sine of 60 degrees. Again, from the table, you probably remember that sine of 60 degrees is a square root of 3/2, right? 2 and 2 cancel, and we have square root of 3. So area of this triangle is equal to square root of 3. I think that's all for this lecture, very short one, just because we already know almost everything, and even area formulas. I don't think that you've never seen them before. Okay.